In this video, I'm going to show you how to simplify fractions. If you have previously learned how to find equivalent fractions, you discovered that when you take a number, for example 5, and we multiply that number by one whole, we don't change the value of the number, we still get 5. Matter of fact, I can do that with any number. If I take the number 25 and I multiply by one whole, I still get 25. I can even generalize this and say when I take any number n and I multiply it by 1, I'm left with that same number n. We call this the identity property of multiplication. It says that when we take a number and we multiply it by 1, it does not change the value of that number. You also discovered that that same property applies when we divide numbers. So I can also do 5 divided by 1. That gives me 5. 25 divided by 1 equals 25. And I can apply that to any number n and say n divided by 1 equals n. So I'm going to use this property to help me simplify fractions. Let's look at an example. Let's say my fraction is 24 over 32. That's very clearly not simplified because I have a whole lot of parts in my denominator, 32 parts. And I can tell right away that my numerator and my denominator share common factors. And anytime my numerator and my denominator share a common factor, I could write my fraction in a simpler way and have it still have the same value. So my task now is to try to figure out what common factors do 24 and 32 share. Now, when you're first doing this, you may want to, out to the side, list all the factors of your numerator and your denominator. So of 24, I have 1 and 24. I have 2 and 12. I have 3 and 8. And I have 4 and 6. For 32, I have 1 and 32, 2 and 16, 4 and 8. So when I'm simplifying fractions, I'm looking for what factors do I have in common. So I'm going to go through and circle all those. I have 1 in common, I have 2 in common, I have 4 in common, and I have 8 in common. I'm now going to divide my fraction by the greatest common factor, which in this case is 8. So I'm going to divide the numerator and the denominator by 8. Notice that this is one whole, so I'm not changing the value of my fraction. When I do 24 divided by 8, I get 3. And when I do 32 divided by 8, I get 4. My simplest form of 24 over 32 is 3/4. Now, notice on here, if I had chosen a different common factor, such as 2, I could still do that. I'm still finding equivalent fractions. It's simply going to take me longer because now I have a new fraction, 12 and 16, which now still shares, the numerator and the denominator still share common factors. So now I'm going to have to think of all the factors of 12 and all the factors of 16 and start the process again. In this case, they shared 2 again. And now I'm left with another fraction that shares a common factor, in this case of 2. You'll notice eventually I will get all the way to 3/4, but I had to divide by 3 versions of one whole. Now, if we look at this, what I really just did here is I really just divided by 2, 2, and 2, or 2 to the 3rd power, which equals 8, which is exactly what I did up here. So it will help you save time if you choose the greatest common factor to simplify by, but you can still get there if you choose a different common factor. Let's look at another example. So in this example, let's do 18 over 36. If I were to list factors of 18, I have 1 and 18, 2 and 9, 3 and 6. Factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then 6 in itself. So looking for common factors, I see a common factor 1, 2, 3, 6, 9, and 18. The greatest common factor is 18. If I divide this by 18 over 18, I'm finding an equivalent fraction, a fraction that has the same value. So 18 divided by 18 is 1, and 36 divided by 18 is 2. 1836 is equivalent to 1/2. If I didn't immediately know that 18 was a common factor of 1836, I could have chosen any common factor that immediately leapt out to me in my mind. So to me, the most obvious one that leapt out to me was 9. So if I had divided 9 over 9, divided it by 9 over 9, I would have gotten 2 over 4. Then I would have had to repeat the process by saying what common factors do 2 and 4 have. 2 and 4 are both even, so 2 goes into both of them. 2 divided by 2 is 1. 4 divided by 2 is 2. Again, I'm still getting that simplest form as 1/2. It just took a few more steps. So you can see when I divided by the greatest common factor up here of 18, it accomplishes the same thing as dividing by 9 and then dividing by 2, because 9 times 2 equals 18. It is obviously just faster to divide by 18 than to divide by 9 and then divide by 2. Here's another example, 50 over 60. If I were to list all the factors of 50, I would have 1 and 50, 2 and 25, and 5 and 10. Of 60, 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and squeezed in here 6 and 10. So if I'm looking for my greatest common factor, it's going to be the 10 right here. I do have other factors, you'll notice, of 1, 2, and 5, but the biggest factor that 50 and 60 share is 10. So if I divide by 10 over 10, I will get 5 over 6. And as long as my numerator and denominator share no more common factors, I am in my simplest form. Again, let's look at what would have happened if I had chosen 2 as my common factor. If I divide by 2 over 2, I get 25 over 30. Then I have to look for 25 and 30, any common factors. 25 and 30 both share a common factor of 5. 25 divided by 5 is 5, and 30 divided by 5 is 6. Notice again, I get to that same simplest form, but it took more steps because I divided by 2 and 5 in separate steps, rather than dividing by 2 times 5 equals 10 in the first step. Let's look at one last example of simplifying fractions, and I'm going to choose a much more complex fraction this time. And I'm doing this to illustrate the point that when we're simplifying fractions, it's not practical for us to list all the factors of the numerator and all the factors of the denominator on paper every time. Realistically, this is something that you are doing in your head within a matter of seconds. So mentally, you're scrolling through everything that you can think of that these two numbers have in common. And you're looking for the largest one that you can come up with in that matter of just a few seconds. So looking at these two numbers, 128 and 512, I don't have, in my mind, I don't have anything that's any larger than 2 right off the bat. So I know that these are both even numbers, so I am going to go ahead and start dividing by 2. Now, if I had come up with something larger than 2, I would have started with that number. But within just a few seconds, I want to get working. I want to get dividing so that I'm actually making my fraction simpler as I go. So when I start dividing here, 128 divided by 2, gives me 64. And 512 divided by 2 gives me 256. I'm now in the same position where I have to look for common factors of 64 and 256. If you recognize that they're both even numbers but don't see any other common factors right away, go ahead and divide by 2 over 2 again. 64 divided by 2 is 32. 256 divided by 2 is 128. I again recognize that they are even numbers, but I don't know any common factors, so I'm going to continue dividing by 2. 32 divided by 2 is 16. 128 divided by 2 is 64. And I see another common factor of 2. If I pull that factor of 2 out, I will get 8 over 32. And eventually, your fraction will get simple enough that you may notice that there is another factor that you can pull out. In this case, I see a common factor of 8. So now I get 1 over 4, and 1 and 4 no longer share any common factors. Now you may have realized that way back here, we could have taken 16 over 64 and divided by 8 over 8 right there, and gotten 2 over 8, and then divided by 2 over 2 and gotten 1 over 4. I even could have right here, I could have divided by 16 over 16 and gotten to 1 over 4 right away. And a matter of fact, I could have at the very beginning, my greatest common factor in this case was 128. If I divided by 128 over 128, I would have gotten straight to 1/4. But most of the time, if you're working with complicated fractions or larger, more complex fractions, most of the time you may not immediately mentally see that common factor. It is much more time effective to go ahead and start dividing by a factor that you do see in your head, and eventually you will get to a simpler fraction like 16 over 64 or 8 over 32, where then you can jump into dividing by a larger factor.